The manager of a bookstore wants to predict sales from the number of salespeople working using the accompanying data. Complete parts A through H below. Okay, so we need to look at the data because the first part A says find the slope estimate B sub 1. Okay, so as you probably know by now, most of these problems are going to want you to do these by hand, and we're not going to do these by hand. Although there are some nice little formulas that can kind of emerge from this, and I think I show you one or two in the video. I'm primarily, with these problems, going to do what I would do if I were doing it, and that is going to use Statcrunch. So let's go ahead and open this in Statcrunch. Okay, and here's our data. Always make sure it comes in, at least with the headings kind of looking correct. Occasionally it does not, but so I'm trying to find those that don't. So this one does come in well. You can make these columns a little bit longer if you need to. Okay, so let's go ahead and run some stats on this. So go to Stat, Regression, and Simple Linear. So and if you'll notice, I closed this down. The manager wants to predict sales from the number of salespeople. So the number of salespeople is the explanatory variable, so that's my X. And the sales is the response variable, the Y. Okay, so let's pull this back up. Okay, number of sales, sales in thousands. Okay, and we'll just make sure it does graph the line. So even though there's not a place here, at least there may be another part that asks you to graph it. We always want to look at the graph and you make sure that even running a regression is something we should be doing. Now, textbooky problems, often all of them are worth doing. But in reality, when you're doing your own research, you need to create some summary stats and or some visuals. So this does look appropriate. It looks like it is behaving linearly. We did a lot of that in the last chapter. So let's go back here. Here is my equation right here. Made it longer. It wrapped the number of salespeople working down on the next line. Kind of hard to see. So sales in thousands equals, there's our equation there. 7.534 plus 0.8763 times the number of salespeople working. So what is my slope B1? So my slope is the value right here. And I was looking for the rounding. We round to 3 decimal places, so we're going to have 0.876 right here. That's my slope. So I did want to show you, if you want to do this part by hand, if they give you R and the standard deviation of Y and the standard deviation of X, which they do, it's all right here in the problem. They give us R, 0.971, and they gave us standard deviation of X, standard deviation of Y. This is sort of the formula way to do it. We did, I think, one of these, maybe 2 by hand in the video. We can plug all that in. 0.971 times 0.552 divided by 6.11, and we get 0.877. Which is practically the same thing we get here, 0.876. It's off in the thousandths place by 1. And this should tolerate a difference by in the thousandths. If it ever does not, and you get it kind of wrong without figuring that out, let me know and I can override it, particularly if it's a multi-step problem. This is like a seven-part problem, so you wouldn't want to do the whole problem again if you just missed that one. Just let me know about it, and I can easily override that. Okay, now, and this is probably the harder part, now we want to interpret what that slope means. It's one thing to find the slope, but see, computers can find the slope. What does a person need you for? We want to be able to interpret. What does that mean? So it means that on average, and this is where I need to go back to the equation. So what does the slope mean? On average, for every additional salespeople working, I get 0.8, the slope, 0.876 times 1,000 more sales. So let's see which one matches that. So it means that on average, an additional increase of, this is where you have to kind of, the slope, whatever that is, in this case 0.876 times 1,000 in sales is associated with each additional salesperson working. So write that equation down. And so when you look at it, it'll say sales in thousands. So each additional salespeople or person working, what are we gonna do? We're gonna multiply it by 0.876, add it to 7.543, and then that'll be the sales in thousands. So now find the intercept, and we've already done that. Switch back over here. Here's the intercept, 7.534, round to 3 decimal places. Similarly with the slope, there's a formula. B sub naught equals y bar minus the slope times x bar. And we just plug in those values that we had for the average, the slope, and the x bar, and we get 7.527, slightly different. And again, here they provided those values for me. It's off by a little bit, but not by much, and it should be close enough. We should be able to, it should give you credit for that. Okay, so what does this mean in this context? Okay, it means that on average, the expected sales is, and then again, think about what our B sub 0 was, 7.534 times 1,000, with 0 salespeople working. Does not make any sense, right? It's unlikely that any sales would be made with 0 salespeople working. So the slope has a definite meaning. The y-intercept sometimes doesn't really match reality. Remember, all models are wrong. Some are useful. That particular piece of this model, it's sort of hard to interpret in this particular context, right? And this is very common with the y-intercept. Now write down the equation that predicts the sales from the number of salespeople working using the variable x to represent the number of salespeople working. And we've already kind of done that. Again, here's our equation right here, 7.534 plus 0.876 times number of salespeople working. Okay, now we're going to use our equation to make a prediction. So if 19 people are working, what sales in dollars do you predict? And we're going to use our equation here. Okay, so when I plug this into the equation, put in 19 for x, I get 24.178. But step back for a second. With 19 people working, I want to make $24. Doesn't make a lot of sense. And then hopefully remember, wait a second, the sales are in thousands of dollars. So let's multiply this by 1,000. So we get 24,178. So it says round to the nearest $10. So 24,180. So if the sales are actually 25,000, what is the value of the residual? So just recall that the residual equals the observed minus the predicted. So our observed was 25,000, so we actually observed. And our predicted was 24,180, so the residual is 822. So this final question just says, has the original estimate from part F overestimated or underestimated the sales? So here was our predicted 24,180, a little bit under what actually happened. So it underestimated. So I hope that helps.